When conditions are right, we can enjoy the northern lights, but forecasters at the Space Center Prediction Center are busy focusing on the impacts these solar storms have on our society. Meteorologist Jacob Morse explains.
Located in Boulder, Colorado, the SWPC monitors the sun for impactful space weather that could disrupt systems on our planet. Coronal mass ejections are explosive plasma eruptions from the sun's outer atmosphere, and if directed at Earth, they can not only result in a viewing opportunity for the aurora, but also impact our infrastructure and technology. The Space Weather Prediction Center constantly communicates with industries that could be affected.
Whether it's the power grid, which can be dramatically impacted by an extreme space weather event to the point of potential collapse. That's the main federal government concern there. Satellites, operating them properly, astronaut health, aviation can be harmed by radiation exposure due to extreme space weather events of a certain type. GPS accuracy, which is important to North Dakota. A lot of the combines and things are using precision GPS to navigate and be within accuracy of inches, right, when they're working on their crops. That can be dramatically off the mark when it comes to an extreme space weather event as well.
The intensity of solar storms is placed on a scale from 1 to 5. When activity reaches G3, the SWPC calls coordinators responsible for most of North America's power grid to allow them to mitigate potential problems. These forecasts can change rapidly with the vast distance from the sun to Earth.
We're trying to predict activity from the sun 93 million miles away. What's it going to be like by the time it gets to that satellite a million miles from Earth and then ultimately at here and around our planet? Very challenging.
As we approach the maximum of a solar cycle later this year, the increased solar activity should keep SWPC forecasters busy, safeguarding our society with actionable space weather information. For your news leader, I'm Jacob Morse.
Jacob will have more on the National Centers for Environmental Prediction next week, talking about the Environmental Modeling Center. Meteorologists use a variety of computer models to make forecasts, and many of those models are developed by the Environmental Modeling Center. Jacob Morse explains how weather predictions have improved thanks to new research.
Located in College Park, Maryland, the Environmental Modeling Center consists of 3 branches that work together to create, sustain, and upgrade more than 20 weather forecast models. Some of these models solve the complex equations that simulate our atmosphere globally, while others focus regionally at a higher resolution. All utilize a grid system where more grid points mean more fine details in the forecast. This also increases the necessary computing power, requiring massive supercomputers. We do our best to capture the current state of the atmosphere as a starting point for the models to forecast variables such as temperature, precipitation, and pressure.
One of the biggest things that we've done in the last 25 years is improve the observations of initial conditions. So we're capturing the atmosphere in its current state better, and that's because of the advent of satellites that are, more numerous and help us get data from places that were data sparse before.
Once the models are developed, the Environmental Modeling Center evaluates them with statistics and case studies to find biases and issues.
Say in winter, over a certain region, temperatures coming out of a particular model are always too cold. That you could see in an average statistical sense, but then you could also find individual cases to prove that point.
While models have improved greatly in the past few years, for example, now able to distinguish different types of frozen precipitation, much more is possible in the future.
Artificial intelligence and machine learning could lead to huge improvements, and it's not that computationally expensive once the training is done.
They're trained using several decades of historical weather data to increase accuracy and speed. AI might also help develop new products from models. For your news leader, I'm Jacob Morse.
Jacob will continue this series on the National Centers for Environmental Prediction next week, talking about the Climate Prediction Center. Weather forecasts are not an exact science, but we're getting close with new technology. However, the longer you look into the future, the uncertainty increases. Jacob Morse explains what kind of forecasts the Climate Prediction Center makes.
Climate is what we expect. Weather is what we get. This distinction is important when we compare our 30-year climate normals to the forecast. The Climate Prediction Center makes outlook maps for temperature and precipitation for the next 6 to 10 days, 8 to 14 days, 3 to 4 weeks, 1 month, 3 months, and upcoming seasons. The colored shading on the map indicates the degree of confidence the forecaster has. The darker the shading, the greater the level of confidence. In between means equal chances of above, below, or near normal as uncertainty is higher. Some weather forecast models are helpful in creating these outlooks, but teleconnections, or links between weather patterns around the globe, can often be the best signals for the longer range. El Niño and La Niña might be the most well-known teleconnection, but different ones can override each other or work together to amplify the signal.
This can be characterized as a small signal, large noise problem. And so you are just getting these shifts in a probability space, and you need to understand that, so that if we say it's a 50% probability of being above normal temperature at your location, that means a 50% probability of not being above normal. And so you have to look at both sides of that coin.
As forecasts improve with more data and even the use of artificial intelligence, the Climate Prediction Center continues to expand how far into the future they can reliably predict and the types of products they're responsible for creating.
We also do the Atlantic Hurricane Seasonal Outlook. We're partners in the U.S. Drought Monitor. We also partner with the National Integrated Drought Information System.
For your news leader, I'm Jacob Morse.
Next week, Jacob will tell us more about the Weather Prediction Center. Since weather forecasts can get rather complex, the Weather Prediction Center creates products that communicate the impacts nationally while focusing on extreme weather events regionally. Jacob Morse explains.
To get a snapshot of the current pattern, the Weather Prediction Center draws surface analysis maps with fronts and areas of high and low pressure every 3 hours. They serve as a starting point for national forecast maps that project these fronts into the future, serving as an easy-to-understand snapshot of hazardous weather expected in the next few days. The WPC also creates precipitation forecasts that combine many weather forecast models into one map that meteorologists adjust.
So it's kind of our job to analyze those models, decide which ones we like, and then we have specialized blending tools at WPC that we use.
For areas expected to get a lot of rain in a short time, WPC draws maps highlighting areas at risk for flash flooding on a scale from marginal to high.
We don't issue high risks on our excessive rainfall outlooks very often, but when we do, they need to be taken seriously because they do account for the vast majority of deadly flash flooding days.
This is typically associated with thunderstorms and tropical cyclones.
We work really closely with National Hurricane Center during the tropical season to provide rainfall and flash flood forecasts for landfalling tropical systems.
Localized areas are also identified for imminent flash flooding by the WPC. In the winter, various products are produced by the WPC to communicate the severity and probabilities of snow and ice. The Weather Prediction Center is at the foundation of communicating the nation's weather story 24/7, helping fellow meteorologists and the public. For your news leader, I'm Jacob Morse.
Next week, Jacob will tell us more about the Storm Prediction Center. Well, predictions around here seem rather encouraging, Kevin.
Yeah, that's right. Good looking weather for the weekend. Here is a Weather Prediction Center outlook for the next 7 days on precip. And what I like about this, a lot of computer modeling, as Jacob mentioned, but you've got to have that human interpretation, meteorologists looking at this data. And that's why it changes every day. But even with this storm, we said most of that rain would be in Montana. That's exactly what happened. We've been forecasting that for over a week here. Well, now the trend for the next week, and we're going to see this come true because already things are set in motion for a lot of moisture here for the southeast states. The Gulf Coast area could have between 3 and 6 inches of rain.
Accurate severe thunderstorm predictions help us prepare for and stay out of harm's way from hail, damaging winds, and tornadoes. Jacob Morse explains how meteorologists in Norman, Oklahoma are responsible for forecasting severe storms across the country.
From highlighting the potential for severe storms 8 days beforehand to defining the risk more specifically in the 3 days before an event, the Storm Prediction Center draws outlooks pinpointing the threats. The scale ranges from Level 1, isolated severe storms possible, to Level 5, widespread severe storms likely.
The categories are actually driven by probabilities for each individual severe weather hazard, that being tornadoes, large hail, 1-inch diameter or greater, and severe winds of 58 miles per hour or greater. Those categories are coverage based due to those probabilities, but they all also have to do with the potential intensity of storms as well.
On the day severe storms are expected to develop, the SPC identifies areas of increasing risk and, if conditions warrant, issues watches in coordination with National Weather Service offices. Since there are some similarities in the forecast process, the SPC also is responsible for determining where the potential will be in the coming days for large wildfire ignition and spread. With dry vegetation in place, low relative humidity and gusty winds can cause this.
We use an ingredients-based approach, that being looking for certain ingredients to come together in time and space to support that enhanced severe risk, or in this case, the fire weather risk.
New technology and tools are always being developed at the SPC.
The availability of so much data, that being the high-resolution model guidance, ensemble data, and now the latest artificial intelligence tools.
The severe weather experts at the Storm Prediction Center use all this data to help us understand the risks to keep us safe and prepared before the storms or fires develop. For your news leader, I'm Jacob Morse.
Next week, Jacob will tell us more about the Ocean Prediction Center.
Oceans cover vast distances, making the forecast that the Ocean Prediction Center produces both challenging and valuable to ensure the safety of those at sea. Jacob Morse explains.
Cruise ships, oil tankers, fishermen, sailboats, and container ships. Anyone in the open ocean is vulnerable to dangerous weather conditions that can put life and property at risk. Around 90% of world trade is carried by the international shipping industry, and ensuring these ships arrive safely is the job of the Ocean Prediction Center. That starts with surface analysis maps of where fronts and storms are.
There are not a lot of observations out over the oceans, especially relative to the number of observations that we have over land. So for doing the surface analysis, we're heavily dependent upon satellite data as well as model data.
High winds can lead to large waves and rough seas, so the OPC issues warnings across the North Atlantic and North Pacific, as well as forecast out to 5 days so that mariners are prepared well in advance to adjust their routes. Forecast products are on their website, but also broadcast over satellite and high-frequency radio directly to ships.
It's actually really cool to be able to see the actions that are being taken out at sea, reacting to the forecast information that we put out.
Additionally, ice and snow cover is monitored across the Arctic, Antarctic, and Great Lakes by the OPC for mariners as well as defense and research interests. The basis for OPC's mission can be traced back to the sinking of the Titanic, as it was determined that requirements for safer ocean voyages were needed. Now, forecasters are on staff at the Ocean Prediction Center 24/7 to ensure the safety of hundreds of thousands of vessels at sea. For your news leader, I'm Jacob Morse.
Jacob will continue this series on the National Centers for Environmental Prediction next week, talking about the National Hurricane Center.
Hurricane season begins Saturday, and it's forecasted to keep the National Hurricane Center busy. Jacob Morse gives us a look inside the operations.
Located in Miami, Florida, the National Hurricane Center forecasts the track and intensity of tropical cyclones in the entire Atlantic Basin and Eastern Pacific from their development until potential landfall. This starts with satellite imagery.
We're looking for clusters of thunderstorms that could go on to become a tropical storm or hurricane. So we issue a routine, what's called Tropical Weather Outlook. And as those disturbances begin to organize, that's when we open what we call INVEST.
As it develops into a tropical depression, they'll start to issue 5-day forecasts, and if sustained wind speeds reach 39 miles per hour, it'll get a name. The seasonal outlook is the most aggressive ever, with potentially double the normal number of major hurricanes, category 3 or higher on the Saffir-Simpson scale. This is due to extremely warm ocean water to provide fuel for storms and a developing La Nina that typically leads to less wind shear that would tear apart hurricanes in the Atlantic.
These storms can be highly sensitive to wind shear, as well as dry air. And so it's getting better understanding of that, and really also getting more observations in and around the hurricane to improve the forecasts.
Hurricane hunters fly into the center of storms to determine their size and strength.
When they're flying, the forecasts are generally about 15 to 20% better.
New ways to communicate the hazards associated with hurricanes are being developed.
We've always issued hurricane watches and warnings, but now we can actually put up a warning for storm surge, which has the potential to be the highest loss of life in hurricanes.
Flooding and tornadoes can also accompany hurricanes, so the NHC relies on NCEP partners for these forecasts. For your news leader, I'm Jacob Morse.
Next week, Jacob will tell us more about the Aviation Weather Center. A variety of weather factors can delay flights or cause turbulence when we're in the air. The Aviation Weather Center forecasts these hazards, and Jacob Morse explains how.
Aviation is heavily impacted by weather, from high winds at the point of takeoff to turbulence mid-flight to an impactful storm system causing a plane to be rerouted. Located in Kansas City, the Aviation Weather Center ensures the most accurate and up-to-date weather information is available for pilots. Forecasts are made for icing, as it can accumulate on planes in various situations and levels of the atmosphere and lead to increased drag and weight. The height of clouds off the ground and visibility are also closely monitored for safe takeoff and landing. Turbulence can be caused by a variety of factors, from thunderstorms to mountains to different jet stream speeds called clear air turbulence. Reports are gathered and forecasts are made so planes can avoid extreme turbulence. These are the 3 area forecast desks, but the Aviation Weather Center also issues warnings.
We also have a convective SIGMET desk, which is our warning desk. And that's basically just for thunderstorm warnings for airplanes. So they're watching radar, they're watching satellite trends, and they're also looking at different model guidance to put out an outlook for where they think there will be the potential for development in the future.
Their traffic flow management forecasts serve as a planning tool for the FAA so they can put restrictions or alter routes based on the weather.
Our core partners are really the FAA and our CWSUs, which are Center Weather Service Units, and those are the aviation forecasters that are placed at the air route traffic control centers. They're making these real-time decisions based off of weather and helping planes to make the best use of the airspace.
The Aviation Weather Center also has an international branch for overseas flights and works with other countries to produce global graphics. Additionally, they collaborate with commercial airlines who employ meteorologists.
We want to give everybody the same message. And so it's important that we're all staying on the same page so that we can promote safe and efficient flight across the airspace system.
For your news leader, I'm Jacob Morse.
The Aviation Weather Center recently updated its website to make it more user and mobile friendly.